Dinosaur Story. Dinosaur Muscles. Hi! This time, we're going to learn about the muscles and skeletal movements of dinosaurs. Dinosaurs are wonderful animals. But it's no fun if they don't move. Wouldn't it be fun to walk, jump, run, bite the prey, and wag the tail? Muscles are required to make a dinosaur move like this. Dinosaur muscles are rarely preserved as fossils. So, scholars first identify the skeleton and then study the muscles. They also study the muscles of modern animals, such as reptiles and birds. This is because fossil skeletons alone do not tell us everything about dinosaur muscles. If muscles aren't preserved as fossils, how do we know which muscles were attached to where? If you look closely at the dinosaur skeleton, you can find where the muscles are attached. In these sites, the surface of the bone is rough or bumpy. Muscles are categorized into 3 types. Skeletal muscles that move the skeleton, cardiac muscles that make up the heart, and visceral muscles that move the intestines. Among them, the main interest in dinosaur research is skeletal muscle. This does not mean that only skeletal muscle is important. In order to understand blood circulation, it is also important to understand the cardiac muscle. It's not clear, but a fossil that is thought to be a dinosaur heart has also been found. And in order to understand the digestive system, such as stomach stones, we also need to know the visceral muscles. First, let's look at the basic structure of skeletal muscle. The part where the muscle begins is called the origin, and the part where the muscle ends is called the insertion. And the bulging part in the middle is called belly. When the muscle contracts, the insertion is pulled toward the origin. A single muscle does not move separately. There are muscles that work together in the same direction, and some muscles work in the opposite direction. When muscles on one side contract, muscles on the other side stretch. In this way, several muscles work together to move the body. Dinosaurs must have been muscular animals because they were huge, and they had to hunt those big dinosaurs. But being muscular doesn't necessarily mean it's good. Bulky muscles can exert great power, but they make body movements dull. So, power and agility must be in harmony. Muscles and bones work together to create power and speed. These movements are very similar to seesaws and levers. So, scholars analyze the muscles and skeleton movements of dinosaurs as lever structures. The lever consists of a fulcrum and a beam. It's a simple structure in which the force applied to one end of the lever is transmitted to the other side through the fulcrum, but there are actually many forms. Let's take a quick look at the movement of dinosaur muscles and skeletons with a lever structure. The movement of the lever depends on the position of the fulcrum and the force acting on it. If the fulcrum is close to the input force, the movement speed of the opposite side increases, but the force decreases. Conversely, if the force is applied to a point far from the fulcrum, the speed of the opposite side decreases, but the force increases. This lever structure also appears in the movement of muscles and bones. When the muscles are attached close to the joints, the resultant movement is speedy, but weak. Conversely, if the muscle is attached far from the joint, it's slow, but powerful. It is like the high and low gear of a car. Jaw muscles. Jaw muscles in modern animals differ between carnivores and herbivores. Carnivores have well-developed muscles that pull their jaws backwards. When the jaws are closed, the teeth engage like scissors from the back to the front, effectively slicing through the flesh. In herbivores, the muscles that pull the jaw backward are small, but the muscles that pull the jaw forward are well developed. It is a structure suitable for grinding or crushing plants with all teeth meshing almost simultaneously. Although the muscles of dinosaurs are a little different from those of modern animals, the basic structure is similar. Carnivorous dinosaurs had well-developed muscles that pulled their jaws backward, and herbivorous dinosaurs had well-developed muscles that pulled their jaws forward. Neck muscles. Large carnivorous dinosaurs had very strong neck muscles for hunting. In particular, Tyrannosaurus had well-developed upper and side neck muscles. So it seems that they were able to bite and pull their prey, or shake it sideways. The neck muscles of Allosaurus and Ceratosaurus were not as strong as those of Tyrannosaurus. However, the lower neck muscles were well developed, allowing them to bite their prey quickly. And they bent the neck downward to compensate for the relatively weak jaw muscles. Theropod dinosaurs had very long necks. So how did they support such a long neck? Their neck structure is very similar to that of a crane. Forces act on the neck up and down, respectively. Theropod dinosaurs such as Apatosaurus and Dicryosaurus had well-developed neck muscles and neural spines to which they attached to strengthen the upper neck. On the other hand, dinosaurs such as Mamenchisaurus and Euhelopus had long bones at the bottom of the vertebrae to strengthen the lower part of the neck. This is called the cervical rib. Chest muscles. It's not so easy to float the body in the air. So, birds had well-developed chest muscles for powerful flapping. And the breastbone to which these muscles attach is also well-developed. So, we can see how well-developed the chest muscles are based on the size of the breastbone. The breastbones of flying birds are very large. But the breastbones of ostriches that can't fly are not that big. The breastbones of Archaeopteryx and pterosaurs that flew in the sky are also very small. They wouldn't have flapped their wings as powerful as today's birds. Tail muscles. The necks and tails of theropod dinosaurs are incredibly long and very similar in length and shape. It's the same structure as a suspension bridge to balance the front and back. Paleontologists believe that the neck and tail of theropod dinosaurs were able to balance sideways. Turning the neck to one side, the tail moved to the other side for balance, and the front legs moved in the same direction as the neck. Carnivorous dinosaurs had stiff tails. This is because they could not move swiftly if their tails were wagging. But the tails of theropod dinosaurs were made up of as many as 50 vertebrae, tapering very thin towards the tip. So, they could swing their tails like whips. Ankylosaurus' tail is somewhere in between. The front part of the tail is soft, but towards the back it becomes stiff as tendons change to bone. It seems to be intended to swing the tail club strongly, while shaking the front of the tail flexibly. Modern crocodiles and dinosaurs have well-developed tail muscles. And these muscles help the hind leg move more backwards when walking. However, when modern birds with short tails walk, the knee muscles work mainly, and the tail muscles are rarely involved. Dinosaur quiz. Which of the following animals has the largest chest muscles, relatively? Number 1 eagle. Number 2 ostrich. Number 3 Archaeopteryx. Number 4 pterosaur. The answer is eagle. Modern flying birds have well-developed chest muscles for powerful flapping. The chest muscles of ostriches, Archaeopteryx, and pterosaurs are small. That's it for today. See you next time. Thank you.